So, welcome to Data Science 101. My name is Tomás Barros, and I know it might be difficult to pronounce that, so you can just call me Tom. My background is that I'm currently pursuing a master's degree in computer science. I've worked as an exploratory data analyst for citizen security here in Chile, and I've also worked as a machine learning engineer looking to proactively detect phishing campaigns on the internet, and also I've worked a bit on speech-to-text models. So the big question is, why data science? What is data science? And here I have a quote from my previous project manager at this citizen security job. When he hired me, he told me, we simply have tons of data and we have no idea what to do with it. And this is a very common issue in big businesses. They take all the transaction data, they take all of their daily workings, and they just store it all in a database, and they say, well, maybe in the future it'll prove useful. So my job in this particular company was to look at this set of data, which was the security camera positions, the amount of crimes that they detected yearly, and the amount of false positives that they emitted, etc. And simply see if I could take all this information and make it into something useful. So data science differs from traditional computer science in that it's completely data-driven. So when we have a massive data set, all of the questions that we have to ask about the data set have to be guided by the data itself. And also the way we answer these questions has to be guided by the data. So the first question, once I saw and I plotted this and I made this visualization, the first question that I had was, what if we have too many cameras, right? So we know that each camera has a cost of upkeep. So it would be ideal to have the smallest amount of cameras possible that still covers all of the area that we should be covering. And it is clear from this visualization that the visual areas overlap in a lot of these places. So the first question we had is, what if there are too many cameras? Well, how would we answer that question? Well, we have to somehow find cameras that are redundant. And then how do we answer whether a camera is redundant or not? Well, we can take an example like this corner over here. Let's say this hypothetical example that we have a camera A and a camera B, and they're both side by side and looking at the same position, right? So what we could see in the data, what we could see reflected is that maybe last year, camera A detected 10 crimes and camera B detected the exact same 10 crimes. What do we say then? Well, it is clear that either A or B is redundant because every crime that A detected was also detected by B. But now, if we want to ask, or if we want to answer the question of which of these two cameras we could remove, we would also have to consider how these two cameras interact with all of the other cameras in the vicinity. And here we have a classic data science problem being solved just through the use of the data that a business has stored. Another question that we could ask is, what if we wanted to place a new camera? Where would we put it? So if we just used a heuristic, a simple algorithm, we just thought, let's place the camera where it is furthest away from the most amount of cameras possible. So maybe that would give us an answer such as in here or over here. But then if we actually use a data science approach to answer this question, we should also be considering what is the prior probability of there being a crime in each of these areas. So what we're doing in the end is we're considering many points in space, and then we're building a measure of how much would a camera being placed here benefit the business, right? We also know that there might be additional benefits and there might also be costs associated with the upkeep of a new camera. So we have to take all of these considerations into account. Data science, in the end, can simply be summarized as taking data and making something useful out of it, whether that is charts and graphs, as in business intelligence, where we want to just learn how is the business doing, what can we do? Or it could be building a machine learning model using this data to train it, so we could predict prices or something in the future. Data science is simply turning data into whatever is useful for the business. And to end here, we have a bit of an interesting question, a statistical intuition question. So you are playing a dice rolling game with your friends, and you are losing just horribly. You need your next roll to be higher than 10 to win, but you must choose from a set of dice and cannot look at the die faces before making a decision. You do know, however, the average value of each die. So this is classic contrived example just to like prove a point with statistics. So we have 3 dice. We have A, B, and C, and their averages are 9, 7, and 6. The question is, which die should you pick? Well, if we only have this information, then clearly the best die is the A, right? Because it has the highest average. And if we picked the die with the letter A, then we would be very wrong, because there's more information that we haven't considered. So if we now have the average and the variance of each die, we would see that die A has a variance of 0. And variance of 0, as we know, means that all of the values on the die are equal. They're all 9. So it would be impossible to win. We would have a 0% likelihood to win using die A. Not only that, but die B also has the second highest average, but has a very small variance, meaning it likely has values around 7, so maybe 8, maybe 6, but it's unlikely to have a value higher than 10. However, die C, even though it has the lowest average value, has the highest variance, of a variance of 26. So it's likely that it has values like 15, like 20 on some of the faces, and also values like 1 and 2. So actually, if we consider just these 2 pieces of information, then it's clear that die C is the best dice to choose to win the game. Not only that, but we can actually go one step further, and we could see, like, what if we actually have the information on the die faces? Well, then we could make a truly informed decision. But we usually don't have so much information. So data science is always about considering how we can use the data that we have to make correct decisions. And it's interesting that sometimes we can hide some of this information to guide someone to make wrong decisions. And this is, of course, what some politicians might do with, with charts and all. And that's basically, yes, statistical intuition. That's just an example of how we can lie with data, but also how we can lie to ourselves and get mistaken. Now, supposedly the title of this slide should have been variation versus variability, and it should have explained that difference. But as far as I'm concerned, variability is strictly defined in data science, either as uncertainty or as variance. But variation kind of doesn't have a strict definition as far as I'm aware. So I decided to use this example which is an example that I would use in a typical class, just to see like how means and variances can be used to make decisions and also be used to affect them. So I hope it's not too terrible that I didn't explain variation versus variability. Well, this is my submission, my application to the job. So thank you very much for listening.